Well, hello, Algebra 1. Welcome to LFEI2, which is using intercepts. LFEI is linear functions, equations, and inequalities. This second one, though, we've got using intercepts. And what do we know about intercepts? That word, intercept, it crosses something, and that means a lot, okay? What we're going to do is we're going to start with this explore. We're going to identify some intercepts, kind of get us warmed up to this. It says miners are exploring 90 feet underground. The miners ascend in an elevator at a constant rate over a period of 3 minutes until they reach the surface. In the coordinate grid, the horizontal axis represents the time in minutes. That's this guy right here. We got our time up here. Again, this is a weird one. This is in the fourth quadrant graph, but it still works. That's still X. And in this case, the vertical axis represents the miner's elevation relative to the surface in feet. In other words, how far underground they are. And what we have here is miners are exploring 90 feet underground. So at the initial time, at time 0, when we've got 0 minutes, they are 90 feet underground. They're right down here. They're right down here. That's the point that represents the elevation. Negative 90 feet. This is when time, so 0 minutes. Let me rewrite that. 0 minutes, negative 90 feet. And so we plotted that, right? Now what we're going to do is plot the elevation. So it says they ride at a constant rate over a period of 3 minutes until they reach the surface. So it takes them 3 minutes to get to 0 feet below, or 0 feet below, right? Because at 3 minutes they're at the surface, they're not going to keep going up, right? They're going to get to the surface. I hope not, because that means like the elevator is shooting way out of the sky. It's a Willy Wonka elevator, right? In this case, they ride at a constant rate for 3 minutes. That's a pretty good line for me. So in other words, at 3 minutes, they are 0 feet underground. We've just connected the points with a line segment. And where does it cross the y-axis? Well, we're right here. This is our y-axis, right? Where does it cross? At negative 90. Where does it cross the x-axis? That's right here. It crosses at 3. Right? If you think about it, when we write coordinate points, we write x comma y. And this point right here, this is when x is 0, y is negative 90. And over here, this is when x is 3 and y is 0. This is going to become really, really important when the x's and y's are 0. So let's go ahead and look at this thing. It says the point where the graph intersects the y-axis. And the question is, will the point where a graph intersects the y-axis always be the lowest point on a linear graph? The answer is no. Because you might have a graph that looks like this. And would the y-intercept be the lowest point? No, it will not. All right, let's continue on. Let's get into the meat of things. Determining intercepts of linear equations. The graph in the Explorer intersected the axes at 0, negative 90, and 3, 0. This is really, really important. That's why it's in bold. The y-intercept of a graph is the y-coordinate of the point where the graph intersects the y-axis. The x-coordinate is always 0. The x-coordinate is always 0. It's going to be 0, y-intercept every time. The x-intercept, it's kind of the reverse of that. Where the x-coordinate, where it intersects the x-axis. The y-coordinate is always 0. So it's going to be x-intercept, 0 every time. So how do we find the x and y-intercepts? If we're trying to find the x-intercept, again, star this. To find the x-intercept, replace y with 0 and solve for x. We literally plug 0 in for y. 3x minus, well, that's 0. I just get 3x equals 6. Divide both sides by 3, and x is 2. The x-intercept is 2. The coordinate point would be 2, 0. If I'm trying to find the y-intercept, you put 0 in for x and then solve for y. Well, 3 times 0, because remember, that's where x was. 3 times 0 is 0. I've got negative 2y equals 6. Divide both sides by negative 2, and y equals negative 3. We replaced x with 0. found our y-intercept. Okay, this is it. This is it. This is all we got. All right, this is all we got. Negative 5x plus 6y equals 60. To find the x-intercept, replace y with 0. Because again, the x-intercept is where y equals 0. All along that x-intercept, all along that x-axis, y is always 0. So if we replace y with 0, I've got negative 5x plus 6 times 0. Well, that's nice because 6 times 0 is 0. Negative 5x equals 60. If I divide both sides by negative 5, x equals negative 12. The x-intercept is negative 12. If I wrote it as a coordinate pair, this would look like negative 12, comma, 0. To solve, to find the y-intercept, we replace x with 0 and solve for y, because we're trying to find the y-intercept. So I say negative 5 times x, x is now 0. Well, negative 5 times 0 is 0. 0 plus 6y are just 6y. 6y equals 60. You divide both sides by 6. Y equals 10. The y-intercept is 10. In other words, when x is 0, y is 10. If the point 50 is on the graph, is 50 the y-intercept? No. No. Whoops. No. Because the y-intercept is when x is 0. In this case, this is when y is 0. 50 is an x-intercept. 50 is an x-intercept. Well, hey, look at there. We're already at your turn. Go ahead. It'll be a pause, or you pause. Give these two a shot. See what you come up with. Welcome back. Welcome back. Find the x and y intercepts. Once again, to find the x-intercept, you set y equal to 0 and solve for x. And if we do that here, we have 8x plus 7 times 0 equals 28, or just 8x equals 28. We divide both sides by 8 to get x by itself. We simplify this. This simplifies to 1. X equals, I can divide both 28 and 8 by 4. I end up with 7 halves. Do not turn that into a decimal. Leave that as 7 halves. Okay. That's how to find the x-intercept. To find the y-intercept, we set x equal to 0. Set x equal to 0. Solve for y. If we do that, we have 8 times 0 plus 7y equals 28. Well, 8 times 0 is just 0. That's gone. That's gone. I have 7y equals 28. Divide both sides by 7. Y equals 4. If you want to write them as coordinate points, this would be like 7 halves, comma 0. This one would be 0, comma 4. Okay, so follow the steps. Follow the steps. Trying to find the x-intercept, set y equal to 0, solve for x. Trying to find the y-intercept, set x equal to 0, solve for y. I'll do it another way here. If you want to think about it like this, I like my t-charts, you know that. If I'm trying to find the x-intercept, that's when y equals 0. I have to find x. If I'm trying to find my y-intercept, that's when x equals 0, and I have to find y. If I do that, if I try to find the x-intercept, I have negative 6x. Well, this just becomes 0, right? This is just gone because it's negative 8 times 0 equals 24. Divide both sides by negative 6. And x equals negative 4. For the y-intercept, set x equal to 0. So negative 6 times 0 right here, right, to start with. So that's just gone. Negative 8y equals 24. Divide both sides by negative 8. And y equals negative 3. Follow the steps. That's why I had you star that stuff up there. That's why I had you star that stuff. All right. Let's keep going. Let's keep this on a roll. Let's keep this on a roll. Okay. Interpreting intercepts of linear equations. I was very specific in how I talked about this right in the beginning when we talked about the minor. When I said, when my time was 0 minutes, I was 90 feet underground. That's my y-intercept. When x is 0, what is y? And I said at 3 minutes, they were 0 feet underground. When y is 0, what is x? Same thing applies here. We're going to interpret the intercepts for the situation. The Sandia Peak Tramway in Albuquerque, New Mexico travels a distance of about 4,500 meters to the top of Sandia Peak. Its speed is 300 meters per minute. The function f of x equals 4,500 minus 300x gives the tram's distance in meters from the top of the peak. In other words, this is how far away I am from the peak to start. I'm on the ground, I'm 4,500 meters away, okay? And now as I start going towards the peak, that distance closes until I get here. If we try to find the x-intercept, replace y, or f of x in this case, as we've talked about, and solve for it. 0 equals 4,500 minus 300x. I got right here, this would be like negative 4,500 equals negative 300x. Divide both sides by negative 300, and x is 15. 15, what does 15 mean? Because that's down here, right? In other words, at 15 minutes, I am 0 meters from the peak. Notice how I use the x and y. At 15, when x is 15, y is 0. At 15 minutes, I am 0 distance from the peak. We're going to do the same thing with the y. We replace x with 0. The value of the function when x is 0, 4,500 minus 0 is 4,500. In other words, at time 0, when x is 0, at 0 minutes, I am 4,500 meters away from the peak. At 0 minutes, I am 4,500 meters from the peak. Okay. Okay, let's do another one that's not already done for us, right? We've got a hot air balloon. Hot air balloon's up in the air. Hopefully it's up in the air and it's supposed to be, right? It starts at 750 meters above the ground. At time 0, at 0 minutes, it's 750 meters above the ground, okay? But we have a function that describes this. It descends at a constant rate of 25 meters per minute. We've got this function, f of x equals 750 minus 25x. Remember that f of x is the same as y when you're thinking about this stuff, okay? To find the x-intercept, we replace y, or in this case, f of x with 0, and solve for x. So I've got 0 equals 750 minus 25x. I can do one of two things. I can either add 25x to both sides or subtract 750 from both sides. I'm going to get the same thing either way. Negative 750 equals negative 25x. And if I divide both sides by negative 25, thankfully I get a positive number, else this would not make sense. If I do that, I end up with x equals 30. In other words, it takes 30 minutes to reach the ground, right? That's our interpretation. At 30 minutes, it is 0 meters above ground. Let's look at the y-intercept here. To find the y-intercept, we replace x with 0. In function notation, this is kind of cool because we can call this f of 0, or the value of the function when x is 0. 750 minus 25 times 0, well, that's just 0 at 750. The height above the ground when it starts is 750 meters. In other words, at 0 minutes, we're 750 meters above ground. We're 750 meters above ground. Okay. Now, we wouldn't be doing this without having a your turn. So go ahead. We're going to pause. Either you pause or it'll pause for you. Give this one a shot. Same logic exists. To find the x-intercept, we set y equal to 0, solve for x. To find the y-intercept, we set x equal to 0 and solve for y. You refer back to the starred spots. Now that you're back, the temperature in an experiment is increased at a constant rate over a period of time until the temperature reaches 0 degrees Celsius. The equation y equals 5/2 x minus 70 gives the temperature y in degrees. So we know our y values are degrees and x is hours. After the experiment begins, find and interpret the x and y intercepts. Let's do the x-intercept first. The x-intercept, once again, is when y equals 0. Y equals 0, solve for x. So if I do that, 0 equals 5/2 x minus 70. I can do this. I can add 70 to both sides. 70 equals 5/2 x. Oh, now we got to divide by a fraction. It's a good thing we practiced that a lot. When I divide by a fraction, I instead flip that fraction or invert that fraction and multiply. So instead of dividing both sides by 5/2, instead of dividing both sides by 5/2, I'm going to multiply both sides by 2/5. And here's how that works. Remember, this simplifies to 1. This simplifies to 1. I have 2/5 times 70. I can do that. That's like 70 divided by 1. Oh, I can do some simplifying here too. Ooh, I can. 70 of 5 simplified to 14 and 1. So this ends up being 28 equals x. Well, that's great. 28. Yay. Well, what was x? X. Hours. So at 28 hours, at the x being there, what is y? What does y mean? The temperature, y in degrees Celsius. So the temperature, the temp is 0 degrees Celsius. Okay. Let's look at the y-intercept now. With the y-intercept, that's when x is 0. This is y equals, well, 5/2 times 0 is just 0. So negative 70. In other words, what we've got here, at 0 hours, remember, because this is when x equals 0, at 0 hours, the temperature is, and what did we start? Negative 70 degrees Celsius. All right. That's all you got to remember. It's all you got to remember. And we've already done this next part. I'm going to go through it real quick. We've already done the next part. That next part is graphing. Okay. The next part is graphing, right? We've got half y equals 3 minus 3/4 x. It says write the equation in standard form, which is something like something times x plus something times y equals a number. You can do that, or you don't have to. You could just plug in and solve. We've already been doing that. If you want to, it works, right? To find the x-intercept, we set y equal to 0. So 3/4 x equals 3. We would multiply both sides by 4/3. X would be 4. So x is 4 when y is 0, okay? And then in this case, now we're doing 3/4 times x. We're trying to find the y-intercept. What happens when x is 0? We have half y equals 3, and I'm going to multiply both sides by 2/1, and I get y equals 6. So when x is 0, y is 6. Now, there was no like, hey, these are your domain and range. This is just how to graph. I'm going to graph my line through and put arrows at the end. We just found 2 points that we needed to graph through. Drawing a line through them and putting arrows at the end. I did not make any restrictions on domain or range. Okay. Let's look at another one here. We have 18y equals 12x plus 108. You could put this in standard form if you want. Again, standard form is like something times x plus something times y equals a number. You could do it straight from here, and I'm going to. To find the x-intercept, if I do the x-intercept, that's when y is 0. I could say 0 equals 12x plus 108. I could subtract 12 from both sides. I'm sorry, I could add, you know what? I'll subtract 108 from both sides. Why not? Equals 12x. And I divide both sides by 12. Let's see here. If I do 8, get 96. So 9. This gives me 9. 9 times, so negative 9 is x. So when y is 0, x is negative 9. So negative 9, 0, my x-intercept, where it crosses the x-axis. If I did the y-intercept, this is like 18. 18y equals 12 times 0, because our y-intercept is when x is 0. So this is 18 equals 108. I need to divide both sides by 18. And let's see here. Let's see what we get. And if I do that math real quick, you can double check with a calculator if you need to. 108 divided by 18 is 6. So y equals 6. When x is 0, y is 6. So what do we got to do? We draw the line through them because it's not a line segment, and we put arrows at the end. All right. All right. Still going well here. Yeah, again, we graph the line by plotting points -9, 0 and 0, 6, and drawing a line through them. Okay. Number 7 is your turn. Number 7 is your turn. They already graphed it for us, but we're going to double check it for them. Let's do that. We'll be real nice. Use intercepts to graph 3y equals -5x minus 30. Pause, or it will pause for you, and then come back when you're ready. All right, last one. Last one. To find the x-intercept. To find the x-intercept, we're going to set y equal to 0 and solve for x. 0 equals -5x minus 30. Let's try that one more time. -5x minus 30. I'm going to solve for x. I'm going to add 30 to both sides. I get 30 equals -5x. Divide both sides by -5. And I get -6 equals x, or x equals -6. In other words, when x is -6, y is 0. That's right there. Okay, I'm feeling good that we did that one right. Feeling good we did that one right. For the y-intercept, that's when x equals 0. So 3y equals, well, -5 times 0, that's just 0. So 3y equals -30. Divide both sides by 3. Y equals -10. So when x is 0, y is -10. I think we've done a pretty good job. Those look both correct. Now what do? Draw the line through them, put arrows at the end. Our line's better, even though it's not straight. It's fine, whatever. Do the best I can. And there we go. There is intercepts in a nutshell. Finding, interpreting, and graphing. You guys got this. Ask great questions. Have a great day.